You're going live?
This hangout is on air, Cloud Foundry After Dark. So we're starting with a small crew, but I'm sure we'll grow. So I'm Andrew Clay Schaefer. We talk about cloud, we talk about foundries. Well, we got Agile, DevOps, microservices, continuously delivered, containers. We're going to get fashion tips from Big at Home. What else we got? Cloud Foundry Foundation. Hopefully that gets live. Get some Cloud Foundry Foundation action on the battlefield pretty soon.
I just got a text from Mark Croft who said he can give us some hot Windows container action.
Hot Windows container action. So we'll get to that. Containers they continue to be hot. Should we start with some container discussion?
I think that's a good idea.
So my favorite container discussion is, well, my favorite of this week. There's a bunch of them. One of my friends in Israel, Avishai, has a blog post about compiling some Docker and having so he was trying to, I think it was on CentOS on one and on Ubuntu on the other, and it was Ubuntu images. And somehow or for some reason, the Ubuntu is compiled with these flags that look for SE Linux, but they don't actually have the file set up. So when he tried to build it on CentOS, it went into, first it said it was failing, and it was failing trying to create a user. And so his first thought was it's SE Linux, and so he disabled SE Linux on the host, and it still failed. And then when he went and straced what was happening, the build was trying to create the home directory, and because the way that the code's compiled in Ubuntu, it detected that SE Linux was there, not that it was even on, but just that it existed. And so then when it went through and tried to do the checks to load the SE Linux, none of those files exist in the root file system on Ubuntu, and so it blew up, which means that there's this implicit contract between the kernel and the expectations that you have in your file system. So I guarantee there's more nuanced things buried in those root file systems that are going to make some interesting portability stories along the way.
And Andrew, to be clear, was this him running like Docker build on a Docker file on two different Linux hosts?
Exactly.
Or was this, okay, this was not actually trying to constitute an image that already existed.
That's right.
It was okay, got it. Yeah, that's pretty fascinating stuff. I see that Google is doing. They're using just a base Debian image that should probably be fairly similar to Canonical for the most part. But yeah, there's definitely we're seeing a lot of our existing customers ask us about using older versions of Red Hat, for example. And so when you look at between someone that's using a 2.6 kernel versus someone that's using CentOS with a 3.x kernel of some fashion, and then now with Ubuntu 14.10 out, there's even a difference between Trustee and that. So like, there's definitely going to be a lot of interesting subtleties here when people try and.
Absolutely. I mean, I think what Avishai's blog post highlights is it's not just the kernel version. It's actually a function of what gets detected as active in the kernel, what's loaded.
Right.
It seems to me like there are going to be two interesting things that would fall out of this. One would be the idea that even if you're running on the same kernel, sharing the kernel, you can run into problems, let alone people wanting to run and not understanding that you're based or bound by that base kernel. But the other will be people demanding the OSs to act more what I would call like the way para-virtualization worked, where things get disabled and customized to support containers better over time. I bet that's something that happens.
I think it's kind of a forcing function to clean up a bunch of those assumptions that everyone who'd been running as a, whatever as a distro, you kind of take it for granted that everything's going to run under that distro with that file system with that kernel, right? Like kind of in lockstep with your releases. And when you move to this world, and at least if you're trying to kind of go with this story that everything's going to be portable, which I'm not sure is going to be true, then you're gonna kind of run into these nuances.
And Andrew, could you put that the blog you're talking about from your friend in the chat? I'd love to take a look at it.
I definitely can. And then if you're more than number 3 into a Hangout, you're auto muted. So Mark Croft has just joined us, and we might as well make some introductions really quick. So I'm Andrew. I do this pivotal thing over here, and we have 4 pivotals, and they can introduce themselves. But then we are also joined by we're splitting half screen with Dave McCrory from Basho, and then his better half, Carolyn, who works for GigaOM. And maybe you guys can introduce yourselves, and then we'll get back to talking about some technology.
Sure. So I'm Dave McCrory. I'm the CTO of Basho. And
what do you guys do over there?
We do lots of things. The main thing that we're known for is React, which is a distributed NoSQL storage solution, primarily key value and object storage.
And I'm Caroline McCrory. I am a researcher at GigaOM Research, where I tell everyone that they're stupid and they have to prove to me otherwise.
Well, we're here to prove how stupid we are. Cloud Foundry after dark on Sunday. So who else would? Mark, you want to introduce yourself? I think you had some stories to tell us.
Sure. I'm Mark. I'm a product manager at Pivotal, and I'm in charge of the .NET stuff now.
So with that, why don't we just dive into? There's been some interest on the Twitter to talk about Windows, both .NET support and then containers on Windows, and where we think that's at and where it's going. And I don't think anyone knows that world more than you, at least in my circle. So maybe you could tell us what's going on.
Yeah. So Microsoft has made a bunch of announcements in the past couple of weeks, starting off by saying that they're partnering with Docker, and they're going to take a research project that they did a couple years ago called Pico Processes and formalize it in the Windows Server 2016 kernel, which is pretty amazing. We're excited that Windows is going to catch up with Linux from many, many moons ago, but we're excited to use it for Cloud Foundry because in Windows right now, we have a team in New York that is developing a Cloud Foundry container technology on top of the Windows kernel, and without having formal isolation in the kernel, it makes it very hard because we're always just working to isolate the best we can with the user access in the kernel we have today. But that's what we're working on now. As soon as Pico Processes get launched, we'll switch over to that and do the same thing Docker's doing and use the native isolation in Windows Server 2016.
So maybe for people who don't know as much about this, you could explain to the level that makes sense the kind of difference between the way the Linux kernel works and the isolation you're getting from the namespaces and limits you're getting from C groups and all the kind of process control you have on Linux compared to what you are trying to deal with in the Windows world.
Yeah, so in Windows, we don't have kernel namespacing. We don't really have overlay file system, and we don't have C groups or any of the great things we rely on in Linux, but instead what we have is we have the job object that allows you to isolate the impact of a process's access to the CPU, as well as NTFS quotas, which are the traditional user quotas have been in Windows since Windows NT, that allow you to isolate the file system access and the impact to the underlying disk system. And then we also have some pretty cool features within the IIS server, that's their web server, that allowed you to do pooling of resources to be able to isolate a web app from a different web app. Some big things that we're missing between Linux and Windows would be a virtual networking bridge. Linux has its bridge that allows you to create virtual networks on top of containers. That's one thing that is kind of hard to mock up in the Windows environment. And the overlay file system, we have no concept of that, so whenever we spin up a container in Windows, unlike Linux, where we are working from a root file system image that we start with, and we just write diffs, and as you change your file system, it just diffs the difference between it. In Windows, we have to actually copy everything you're going to need access to into a separate directory with a quota on it, and you'll make changes there. So the startup time in Windows is significantly more than in Linux. And in addition to that, we can't actually allow you to change a lot of files that would be shared with the system because it would change it for everybody. So there's some subtleties to how we implement isolation in Windows, but at the end of the day, Windows already has isolated workloads between the IIS web apps and background apps, and we're just taking the best of breed of that and automating it.
Why just use that when there was quite a bit of work in the virtual server side of Windows to implement some of those capabilities that you just described? I mean, it seems to me like using that plus the isolation and such that you just went over would put it where it's not that enormous of a leap to create the same container functionality.
Yeah, so I think we looked into using some of the Hyper-V extensions in the kernel, and really the biggest problem with that is we're trying to find a somewhat hypervisor agnostic model of implementing isolation, and we're also trying to avoid some of the startup costs of getting an application on Windows. So when doing the Hyper-V model, you're going to pay the overhead of now you're copying an entire OS image, and then you're starting it up. We looked at pooling maybe warm, started up images of VMs, but now we have this tremendous amount of overhead in the environment where you're just running empty copies of Windows. And on top of that, there's licensing concern and all the rest. So we're trying to get as close to the Linux model where we have a really fast startup experience where you can push your app and just see it running quickly using shared OS resources. So today that means that we're doing a lot of active monitoring of your application to keep it within the resource bounds as you have committed to within your quota. We're hoping as Pico processes develop that what we're adopting today is a closer match to what Microsoft will support when there's Docker support than if we went the Hyper-V model.
That makes sense. I get the Hyper-V model. I was more thinking of, for example, the network side. To me, listing a lot of the capabilities that they had to build in Hyper-V to provide a virtual interface, for example, while not obviously modifying the kernel, a lot of the driver writing and everything else is pretty proven out that they've created. So to me, that should help. Obviously, it doesn't solve the problem. I think as much as any of us would like, I would certainly love to be able to have simply a Windows and a Linux container, and I move both of those around, obviously independent of one another, but move them around, and it solves a majority of my issues. I'm also going to be curious how we see over time being able to deal with some of the complexities around contention. Obviously, things like the Kubernetes stuff with let me contain that for you get more sophisticated in being able to more granularly constrain resources between containers. And I think that's something else that people are going to want with Windows as well. It's just what
the biggest thing missing today on the Windows side is actually the overlay file support, because of all the other things that don't exist in the Windows kernel, that's the most painful, because today a Windows developer is very used to dealing with dependencies that are installed in the operating system itself. So without getting an entire virtual image stood up and the startup time and the cost of have that overhead, there's really no way to have access to like SharePoint shared services, anything that's in the registry, group policy, Active Directory membership that implies group policy action on that VM. Like all those kind of contexts you kind of lose if you build VMs, and without like an overlay file system, there's really no option to get that without paying the startup time per app.
So just out of curiosity, and you know, I'm not going to make you promise anything or hold you to it. What do you think this means for .NET support on Cloud Foundry, and when do you think we'll kind of see viable solutions with the Diego runtime?
Yeah, so we're not really doing any crazy innovation here for Windows containers today. Iron Foundry project a couple years ago really proved out a model that seems to work well. Uhuru has contributed greatly to the idea of isolating Windows workloads for a Cloud Foundry model as well. So what we're doing is we're partnering with all the folks in the foundation. We have people from EMC, HP, IBM, Uhuru, and also CenturyLink joining us to pull in everything that's been developed for the .NET Cloud Foundry v2 stuff and getting it compatible with Diego. So we have the team in New York right now. Their biggest focus is just getting the Windows Diego components stood up. So that primarily is focused on a garden server for Windows using the isolation that is already out there in open source, and also getting the Diego Circus going.
So if IBM's partnering, are we going to see OS2 containers soon?
It's funny because a lot of the multi-stack stuff in Cloud Foundry is not been well tested until now that we have a real different stack. So I think some of the work we'll do with the Cloud Controller and in the runtime of Cloud Foundry will probably help folks if they want to run OS2 or Power or something else. It could be possible.
That would be awesome.
I'm waiting for my Commodore 64 emulator personally, but
All you need is that shared Commodore 64 kernel, and we're all set.
Yeah. I mean, no joking aside, the IBM engineers actually do work with us and collaborate with us in the San Francisco office, and we've definitely heard some things like around power architecture and mainframe stuff. This is not they don't consider it a joke. They're serious.
I just talked to someone on Friday about a labs engagement we have that's working with COBOL, and they're writing a COBOL emulator build pack. So it can happen.
I can believe it. There are so many legacy things out there that people would like to see. Not surprising.
So Mark, just reflecting a little bit on what you're talking about, there's a whole spectrum of capabilities. If you were to sum it up and up-level it to someone, would you say that the Microsoft Windows support you would have in Cloud Foundry initially would be mainly for, if you're going to share a host with someone, you'd probably really want to trust the people you're sharing that host with? Or do you think we'll be able to get to a point before, some future Windows time when they have this Pico thing where you really could have multi-tenant untrusted workloads living on the same host?
Yeah, so a lot of the engineers on the team have kind of come away saying that this is going to be a great technology for a private cloud, but there is an Iron Foundry trial running the same isolation that's public out there. There's a few others that are running a public version of this, so I think we're going to have to look and see how battle-hardened it is before we make any assessment. My gut tells me that Pico processes is when we can really trust if we wanted to work with a telco or service provider to run this in public, then Pico processes are probably needed.
I mean, to be fair, I still think there's probably some nuances about the Linux containers and multi-tenancy that we're going to discover over the course of this.
Yep. Just in the past year, we've made a lot of changes to how we do isolation on the Warden side. The Bitcoin miners helped us a lot this time last year discover some weakness there, but I still think that Microsoft is a good 4 years behind in the game. But I'm hoping Pico processes will let them catch up quick.
Well, I think that they're probably motivated to catch up, which will help.
Yeah, they're doing good things, like doing the .NET runtime and a real open source license and getting that out there. That was cool. Joining with Docker, that's a good sign. The problem is some of the things that we've been talking in public about is all these things that happen with Microsoft are great first steps, but the problem is a lot of their customers are still running Windows Server 2008, some 2003, And so talking about great things in the enterprise with Windows Server 2016 seems like it's forever away from now.
So does that mean that they're going to work on Windows XP containers at some point?
Oh, you did not.
No, actually, Windows 8 had Pico processes in it, apparently. So if you have a copy of it, you can, if you read the docs, you can actually use some of it, but it'll make its formal appearance in 2016.
I mean, in some sense, that parallels the enterprises that have, whatever Red Hat versions and older kernels. They're not able to run Docker today, too. So it's all in parallel.
Yeah, any enterprise that can't move fast is going to have a hard time catching up with this. The difference, though, is that the Linux side of an enterprise that have a slower release cycle and upgrade cycle is going to be ahead of their Windows side.
Interesting strategic idea would be for Windows to provide a copy of the Linux kernel where you could run Linux and Windows containers on Windows.
I think, considering we just talked about how hard it is to ensure portability on top of 2 versions of Linux, it's a ways off to do that.
Well, I agree. I'm just saying it'd be a cool idea if Microsoft did it, that you could run both on their stuff.
I would love a pony.
Well, I don't know how useful it really even be, because just like when they open source the .NET runtime, that is pretty cool because mono is going to be that much better. But if you think about a lot of the enterprise apps out there, they depend on a lot of dependencies from the OS and a lot of libraries installed in the OS. So even if I go and run the entire .NET framework in Linux, that doesn't mean I'm going to have access to the SharePoint services, to the Microsoft queue, to all the group policy type of stuff, like Active Directory resources. None of that's going to just show up in Linux also.
Right. It's more of the vision of, I'm an enterprise that's 85% Windows. I can run Windows containers primarily, and if I need a sprinkling of a few Linux container instances, I could get them and still have a core on the metal Windows across everything.
So you're talking about running Windows that exposes the syscalls or whatever to run the Linux kernel containers,
and having that copy of the Linux kernel living on the Windows system, so it provides equivalent capability. Probably a little slower, probably not in an ideal state, but if I only have a handful of Linux systems that I care about and I'm majority Windows, it'd be pretty handy.
Doesn't that start to look suspiciously like a hypervisor?
Doesn't a container already look suspiciously like a lightweight hypervisor?
No.
No?
I don't agree.
Okay.
I think you could do this today with Hyper-V.
So then what you're saying is that I don't have virtual interfaces with containers. I have real interfaces with containers, and I don't get slices.
It depends on which interfaces you're talking to.
I don't get slices of a processor. I get a full processor, and I don't get slices of memory. I get full access to memory. I mean,
from your perspective, you have access to real metal memory, right? Like it's just going through. There's not emulation of the hardware, your own real hardware. The kernel's limiting your access. Anyway, it doesn't matter, but I think the point there is if you have this slow translation layer that's providing the system calls, then I'm not sure you get anything over just running Hyper-V and running the Linux and then putting the containers in your Linux VMs.
It's less management and more portability that I get because I don't have to go and retool. Sure, I could run Hyper-V, run Linux in that, then run partitions inside of that, and now I end up with the inception problem of not being able to figure out where in the stack I even live. Sure,
I'm not sure what you mean by it. Like, what's the confusion over just like say you're running in a cloud right now and you're running containers? Don't you have the same exact problem?
No,
because you're running in a VM. Isn't that your argument? Or
no. I'm saying in one way, if I'm just using or consuming the service, I don't care. I upload my container and I get to use it and I don't care. That's awesome. If at the same time I'm actually worried about the system beneath because I'm responsible for it, the more layers of software and the more different types of systems I have to deal with, the more complexity I have, and the less I would like to deal with that versus having a compatibility layer if I primarily use Windows, which is the use case I was specifically talking about. I
No, I get
agree.
it. I mean, I guess from my perspective, if I was operating it, like I agree that adding layers and complexity adds to the operational overhead. But then, do I want to run in Hyper-V, which is sort of optimized and tested for however long, or like this new project that someone? If I'm deciding today to run production workloads, I mean, we're kind of rabbit holing on a side topic.
Well, I have a question for Dave. Do you think many people are running Windows on Metal today? Like what's the isn't that Windows operating system you're talking about probably already running in a hypervisor?
Uh, I think it depends. Why would, if that's the case, then we're saying that the only advantage to using containers is the speed. Because if I'm thinking if even if I am running Hyper-V, I'm still running Windows on the Metal. I'm just running Windows also inside of those virtual machines that are giving me strong isolation and arguably emulation, depending on how you want to look at how Hyper-V solved some of the different problems. But otherwise, you're just running Windows on Metal, right?
I suspect most people these days are running Windows. I mean, this is probably an answer we could get pretty easily. I bet most people are probably running Windows on virtualization now, whether it's VMware or Hyper-V or KVM, whatever it happens to be. Does it
I,
even work on KVM? Maybe that's nonsensical, but
It can be
I
made to.
okay. I I I think the value, it's not just a speed value. There's also a density value in doing containers versus full virtualization. But it's this whole spectrum of VMs are going to be full VMs are going to be better at security and give you the best isolation, but they're also going to be using more resources.
so
And
I agree with you, James. I think you're onto something. So the question would be then, would a superior solution be to run containers on Windows for most things, and then if you're a Windows shop, run great big Linux Hyper-V instances that you then run something like a Docker-esque container technology inside of?
I
Is
mean,
that
when you say a superior solution, that's subjective, right? Because I would argue on some level, containers is kind of this stopping point along the way, and a superior solution would be something that looks like unikernels without an OS at all. Like, why do you need to run this multi-user US to run apps that are like HTTP? Doesn't make any sense at all.
totally agree? But if we're talking about I'm a Windows shop through and through, but I do have some Linux apps I need to run.
So
I,
superior solutions aren't really your thing then, is what you're telling me.
no, I'm talking about
I'm
to
just giving
solve
you a
the
hard time.
hypothetical problem that we've created is more of what I mean by a superior solution. I don't mean a general purpose superior solution. The
Right.
hypothetical problem we were discussing.
Andrew, what's an example of something that's doing this? Is it something like zero VM you're talking
Um,
about, or like
LVM's interesting, but I'm thinking more like the Open Mirage or the OSV projects.
OSV? Okay, yeah. I haven't heard of OpenMirage, but definitely heard of OSV.
OSV is like the KVM guys, and Open Mirage is like the Zen guys. There's very similar, or there's some similarities.
I see.
So the Open Mirage is all Haskell, so you got to like level up on your.
Oh, ouch. That's
Well,
painful.
it feels to me like those things might emerge over time, but it feels like it gets very niche and specialized in that the amount of things you don't get in those environments that people are just accustomed to, and especially if there's any legacy in your apps at all, of using some kind of, in the Java world, there's all kinds of people who still have some kind of JNI thing that needs to be, goes down to C code and it has special dependencies on things. So like that, when I've looked at OSV in the past, that's where I've become skeptical of OSV, because I've seen this before with JRocket virtualization when I was at BEA Systems. Yeah, and then Oracle acquired them, and we tried to make use of it at Oracle, and then eventually it was just like there's no one using this thing. It had some interesting performance numbers in the lab, but the reason it was when people tried to use it in POCs, we were customers, they'd always run into something that didn't work well. Either functionally it just didn't work, or on the second hand, the performance benefits weren't there because the things that at the time that the marketing teams had been pumping up like all this great performance, it was focused on like a micro benchmark, and when you looked at the overall application, things didn't go as well because only micro benchmark things were optimized.
The rate limiting steps weren't in that path, so
yeah.
That's what. Well, I think personally, and this is just speculation, and we'll see how the rest of the story goes. That if it follows a similar arc to the way containers went, where you have very similar problems, and we're working through some of them now, that you can't expect all the things that you normally would have to work. And now the containers have really existed and been, if you count the stuff before the C groups, like the OpenVZ stuff, and then the C group stuff, you're onwards of like 8-9 years of containers. And I've seen all sorts of people build all sorts of things along the way, but you didn't really have exuberance for containers in the market until really the last year. And so I wouldn't be surprised if you see unikernels kind of have that 7-year incubation, and then people are all excited about them in the year, 2012 or something.
Yeah.
I mean, not 20. I mean, like 7 years from now.
Sure.
That's I agree. I mean, I think at least from what I've seen in talking to our customers, it's been primarily people are looking and using containers, but they're using them for dev and test. And when I watched virtualization kind of from the beginning and how its usage curve went, it started off in dev and test, and then people started to use it for lightweight production workloads, and then over time they got more and more ambitious, and then finally we're at the point where it's you're going to be virtualized unless you can come up with some type of reason that prevents us from virtualizing. You're doing high performance compute with microsecond transaction where you're worried about latency at that level, or you're doing something with GPUs or some other really wild specific use case. Otherwise, it defaults virtualization. I think the same thing will be with containers in time.
I think containers is adopting a little faster than virtualization did, because we're starting to see some customers already go down the route of putting everything on the PaaS as like PaaS first, kind of like virtualized first campaigns from maybe 5 years ago. We're starting to see that really early. So
I see about seeing its use early. The question is, that would have to be in newly written apps. I'm certainly not going to take my 5-year-old app that isn't written with any of the cloudy design patterns and just toss it on top.
No
but
doubt.
for all new apps, yeah, sure, I'll agree with that.
So unless we want to beat containers to death, should we talk about data? Or what else is there to talk about?
Let's talk data. I love data.
I heard it has gravity. It's kind of crazy, huh?
So there's lots of stuff to talk about data. Where should we start? Or you want to kick? Because Dave, you've done some Cloud Foundry over there before you had your new job, and so you've seen a little bit of both sides of this, and now you're working on kind of a pure data play. So how do you see the things coming together? Obviously, you can't have apps without data. Like, you have to solve the data problem somehow.
Well, I guess my question would be, which data problem are we talking about? There are a lot.
All of them.
All of them. At least from my view, the biggest problem that I think is coming our way is probably the deluge of data, as far as a lot of businesses talk about big data and how they're going to run and get all sorts of amazing things out of this giant pool or lake of data. But I think the reality is the number of data sources that are actually feeding data into the business is what's going to become a huge problem over the next few years. Then dealing with that data on something like your apps in a PaaS is going to become even more difficult and interesting, let alone all of the issues around data that have not been solved. If we talk about the regulation and governments and curation and data management and all of those things, there are tons of problems around data that have not been very well addressed up to this point by anyone I've seen, as well as inside of companies looking at the legacy data they have. There are problems with the data that's inside of companies today. We all make the assumption that, oh yeah, everyone's data, they're all storing it, everything's great. The reality is there are so many problems with data. If you look even inside of a Oracle or SQL Server database or something else, where the data quality inside isn't good enough to even be able to derive and make smart decisions based on that data, the list is incredible.
I mean, in some cases or most cases, that's a function of the hygiene of the app themselves. Like, how the data get into that database in the first place.
Partially, what I saw at my previous position was apps that would be written poorly and wouldn't meet all of, say, a user's needs, and so the users would adapt their use of the app to fill the gaps. So you'd have a notation field, and the user would create different symbols in the front to define the equivalent of other fields. So maybe bang bang or exclamation point, and then a note might be for say one thing, and then pound pound or hash hash might mean something else, and you end up with this giant notes field with a dozen different symbols representing all sorts of different missing fields in the app. And so then you have to go and reconcile that in your pool of data to actually get something meaningful out of it.
So those little dialects that develop, those are solvable because you can kind of translate them back to something sensible. Where I've seen the worst problems is that the data has the schema of the data, the definitions of this is a relational world, DDL or whatever. As the apps have evolved over some period, sometimes even a decade, that each new iteration of the app that might change the schema, no one went back and kind of reconciled. So you end up with all these kind of almost archaeological layers in the data that you can't necessarily translate because the context of how that app ran at that period is sort of lost.
Yes, I agree. If people leave, that's like almost a social metadata that's lost because it's not recorded.
Yeah, that's why I call it. It's kind of like hygiene and discipline. And a lot of people, whatever. Like, there's some pressure to deliver. I mean, we were always talking about speed in the Cloud Foundry conversation, and often one of the things people sacrifice is quality and hygiene in their applications of data.
Yeah.
Like, you basically have to make doing the right thing the easy thing in technology, or most people will do the wrong thing.
I think that's pretty much ubiquitous across any architecture that's been around for more than 5 years. Technical debt, it builds up because you have a speed to market problem. And you architect and shortcut both the architecture for the database, but also the architecture of the applications and how they communicate. And you end up with a mess.
I think that's right. I think that the largest number of messes that probably exist out there are likely with Microsoft Access and in an Excel, because they're so damn easy to input data into, and they can be so easily abused. And so they are.
Does anyone have the URL data entropy? Let's go grab that.
Help if I can spell entropy correctly.
Someone has .com.
Yep, they do. It's for sale, basically.
So yeah, someone's parked on it.
Yeah. It's interesting because, at least from what I've seen, entropy occurs both from people in data, the effect of entropy and kind of what some people refer to as bit rot. You have it from people misentering or abusing schemas or something else, but you also have it purely from problems with systems. You will easily have, if you're writing data, you could have data miswritten by the system. There's a problem in the network when the data is being moved around. There's a problem with the system when it's being written. We have all sorts of occurrences that we see where you keep multiple copies of the data and the data doesn't match. And it doesn't match because of, well, distributed.
So I have a war story from it was an Oracle 10G that I was basically trying to make a copy of it, and there's this one piece of data that every time it tried to do anything with it, it would just crash everything. It would just crash. It wouldn't crash the whole database. It would crash whatever process, and I had to go escalate all the way into Oracle, and like no one could actually figure out what was going on, and I eventually just kind of like skipped that piece of data. And I'm sure it was some weird thing where it tried to write and something got corrupted, and then like all sorts of who knows? I don't know certainly, but definitely see that. So how does that work, or how do you think of this problem in the kind of key value store document NoSQL world that you guys live in?
Well,
is it worse or better?
it's definitely worse because you have a larger number of systems so you have a higher probability of errors occurring. So you have to go back and check. So we use a technique where we true up the data and resolve those problems by fixing and focusing on data correctness. And there are other systems that do similar things to try and go and almost follow an after the fact Paxos fixing, where if you see two copies that are one way and one copy that's another way, you go in and fix that other copy. You can do that upon access of reading and go in and fix it. And some systems, they don't do it at all. It is what it is, and they leave it.
So is now when we start talking about vector clocks and read repair and all that kind of stuff, or?
That's right. You have read repair, you have dotted version vectors, global version vectors, all around vector clocks, yeah. Or you could take a classic locking approach like true time and spanner or something like that. Those are the only ways that people have found to deal with the problem. And the reality is there's no infallible system, and unless you go back and try and do read repairs or equivalency, you're going to have bad data in the system, even just because it's a system and it's susceptible to entropy.
So in a world where you're setting up platforms and enabling self-service rapid deployment to armies of developers, what do you think the implications are on the data systems and kind of the topic we've been having around entropy and I don't know, what kind of ideas you have about maybe how to deal with that?
Well, I think part of it is putting more, it's really, you're talking about where do you put the intelligence, and some of it you could put in the app, or you need some type of intermediary service that provides some of those capabilities. I even see people implement services in the enterprise where they wire together several NoSQL or several modern storage solutions. Maybe it's an Elasticsearch or a Solr along with some type of cache, whether that be cache like a Memcache or a Redis or a Gemfire or you name it, some type of in-memory solution that act as a cache, and then they turn around and have one or more persistent solutions. And then they attempt to try and write a service that wires those together. And when they do, they don't realize that you can end up with drift by not properly truing up all of those systems or synchronizing those systems between one another. And when you do that, it ends up creating a nightmare because you have things that have been indexed but have been deleted, and they still appear on the index, but they don't appear anywhere else when you do a search. Or you end up with things that have been cached that are no longer existent. Or the number of problems that appear, it's very large. and the applications. You don't want to write all that logic into each application that you deploy. That would be a lot of overhead.
It's almost like you need a data platform.
Almost, yeah. What you need at least is services that can handle the majority of the errors and such that are occurring, so that you can do the equivalent of synchronizing your search indices with what's in your data store, for example.
I mean, one of the problems when you start to have this conversation is, I was actually talking more about kind of the hygiene of the process and the people, and where you have a bunch of developers who are throwing kind of random JSON into databases and how you're going to make sense of that later. But kind of what you're talking about, which is also a very interesting topic, is in some cases, like the actual reconciliation of the data systems themselves is problematic. And it's even worse because across the industry, many of these data systems have implemented kind of, what's the right way is there a nice way to say this? They're basically not taking advantage of 30 years of database research and a bunch of papers on how to do this properly, and so they're not proper data systems in a sense. And so then you cobble together several of those and just kind of keep throwing data at it, and then you're going to be losing data. You're going to have corrupt data. It's a function of there's no amount of duct tape and massaging those systems that's going to fix that.
That's right, and that's one of the most common things that I've seen out there is that very thing. It's almost comical in some cases, the amount of things you see, and I've also seen, actually, even without, if we ignore the NoSQL market, there are plenty of companies that have hundreds and hundreds of database instances that they try and deal with, which have duplicate records across all of them. And the attempt, and I'll stress the word attempt, that I've seen to address it is with something like a master data management solution or something else, which is really something that focuses around data curation, data hygiene, data validation, and other things like kind of we're describing right now.
Looks like we coaxed your old partner in crime out of bed.
Yeah, it looks like we did, surprisingly. Hi, Rob.
He's not going to give us the camera, though. Maybe his mic's not working.
Oh.
Oh, well.
There we go.
There's
There we
Rob.
go. Hi, Rob. No microphone?
It doesn't seem to have sound.
Yep, he's muted. I see him mute. Now he's not muted. Can we hear him?
I think he's trying to talk. Oh, well.
Oh, well.
Technical difficulties.
Yeah.
So what else is there on the data topic, or should we go? We're about 45 minutes into this. Let's. Does anyone have any interest in the Cloud Foundry Foundation or some of the things that are happening along the?
Static.
Yeah, no, my cell's working now.
There we go.
So Rob over there at Dell got out of bed to come join in the fun.
I'm not at Dell anymore.
You left Dell? Is that new?
Almost 2 months now. October 3rd.
Where was I? I must have been doing work.
Doing the crowbar thing first time, man.
So you're full time on Crowbar.
Totally. As we're commercializing as Rack N.
Got it. So what dragged you into this? What were we talking about that made you jump in?
You guys, a couple of weeks ago, we had a great conversation, so I figured I'd jump in and see what was going on.
So you haven't been watching us banter about containers and data?
No, although that sounds interesting.
Yeah, you missed some good sparring.
We're bringing back OS2.
OS2, goodness.
The COBOL platform is a service that's on the way.
And don't forget the Commodore 64.
Yeah.
Is that what that link was? All right, I saw that. containers and data scare me just because I don't think you expose the disk subsystems, and it looks like real data systems have to have access and knowledge of the physical data infrastructure.
No, you just keep layering crap upon crap, Rob. You don't know how that works?
I've seen that process used a lot in many communities. Yes.
I've seen that design pattern.
Abstractions everywhere.
Best practices. Yeah, so we're definitely having interesting conversations as we try to do. What's on your mind with respect to all the things you're seeing, or kind of Crowbar's? It's like a bare metal provisioning system with some configuration management and some kind of opinionated ways about how to put some of this stuff together. So how do you see that kind of fitting into this platform as a service world, or as people are evolving their kind of cloud footprints and trying to do hybrid or whatever you want to call the cool new stuff? Where are you seeing, and what are you playing with?
Right.
I do have to say I keep mashing my arrows as I see Rob move around to see if I keep playing a video game or if Rob is actually there. If I hit spacebar, will you jump, Rob?
I'm here.
There we go. All right.
Wait, don't do the Konami keys, though, man. You don't want to see that.
I don't. No, I don't. Andrew's question.
Yeah, so I actually see I see a lot of things about that. One of the things I see about PaaS is that we've been deploying PaaS on top of virtualized cloud, which strikes me as abstractions on abstractions, back to Dave's comment. And so I think that there's room for PaaS on virtualization, but it makes very little sense to me at scale. That the real deal for a PaaS infrastructure is going to be you're containerized on top of bare metal, so that you have less complexity in the overall infrastructure. Because operationally, you want to eliminate everything you can to get the best performance out of the system and make it as easy to troubleshoot as possible. And that's, I mean, from Crowbar's perspective, we aren't very opinionated. We're really an orchestration system that's designed to allow you to take heterogeneous gear and make it look like it's a single underlying platform.
So here's a question, and
Yeah.
have you seen? I know we talked a little bit about this at OSCON on different ways to kind of reboot the way that people do the Pixie and IPMI and all the problems that you have trying to manage these bare metal systems. And then I wasn't aware of this until recently, but maybe you have more knowledge of this Redfish project.
Yeah.
To try to redo some of that. I don't know when it will ever materialize. But then at the point where you can, with an API, provision bare metal machines on demand across a fleet of hardware, that looks suspiciously like a cloud. And why do you need the VMs? And then there's probably a nice conversation to have there. But I think one of the things that you might look at with Crowbar, and maybe this is a bit too much to chew or bite off right now, is it'd be nice to manage those machines with Bosch versus some of the stuff you're doing to orchestrate right now.
You bring it. Bosch would be a total. You could entirely put Bosch as a API using Crowbar's API, and you could crank out configurations like crazy. We do it for Chef Metal, Salt, a couple other things. It's totally doable. So Redfish is interesting, but you're actually adding more configuration protocols. It's sort of this idea of, hey, in a couple of years we might have a converged configuration protocol, but in the meantime you just went from having 8 to 9, and that's on the assumption that all the vendors do it the same way. You could actually be going from having 8 different ways to configure gear to 16. So I applaud the industry for taking steps like that. I think it's important that we start having consistency across systems. But every time I turn around, we're moving the opposite direction. Open compute, even within itself, is different. Dell gear, even within itself, is different. Cisco, HP, there aren't consistencies. Supermicro's
I
pretty
mean,
different.
that to your point, that's what the thing that's killed me when I try to build these sort of pixie infrastructures before, is that you couldn't just bring gear in and kind of put it on the network and expect it to behave. You kind of had to deal with each of the nuances and kind of qualify, or whatever, put the new hardware through the paces and even then there'd be like some quirky kind of probabilistic problems across all of them. So
Right. That's why.
So Rob, back to your point, though, what I'm really fascinated about is, like, today I saw like Lydia Leong and James Waters. They were talking about how Amazon has put like 50,000 to 80,000 servers in a data center, or somewhere in that ballpark.
Sure.
And is it, like, at what point of scale does it make sense to, like, who's using Crowbar and these kinds of solutions right now? It's really the people that are doing this at a scale that they're really forced to, because if you're at a small enough scale, you're having so many of these problems with compatibilities and uniformity and things like that it may not be worth it yet, right?
I also think buried in that, at least if you're looking at Amazon, is they enforce consistency. Like they're not going to go and have this fully heterogeneous random deployment. Like they have qualified certain kind of pods, or however they want to section those failure domains, fleets or whatever. And they're not going to have random gear sprinkled throughout that.
The problem is that because of the gear life cycles, you're going to have variations in gear. Amazon buys enough, and they have enough people that they handle it.
Rob,
but,
I think.
I also think buried in that.
I think though, Rob, you should provide more specificity about variance in gear, because I don't think everybody is thinking.
That's true. So it's not just the vendor, right? It's you add a different NIC card, you get variance in gear. You add different drives, you have different systems enumerate the drives in different ways, so the SBAs are actually not consistent. Even if you patch the BIOS.
Sometimes even when it's supposedly the same part, it's not. It doesn't.
Correct.
That's right. You could have 5 servers that are all supposed to be the same, and each one has a component that has a different BIOS or firmware revision number on it, so it behaves differently.
Right. Well, and then you even could take gear that appears identical in the node itself, and then it's racked and wired, and there's variations just based on its physical topology that you have to take into account. So when you're configuring systems, it's not just the node itself. You actually have to be aware of which switches and top-of-rack gears it's connected in, which network segments it's in. All these. This is the fundamental difference that we learned over the last couple of years between physical gear and cloud. In physical gear, you have to deal with basically the thing you get is there. You have to cope with it. You have to adapt to it. You have to deal with whatever the topology is and the system is and how it enumerates. And that's part of bringing the gear up and making it work. And if you can't cope with that, you can't automate it. And so Amazon spends a lot of time, Facebook, right, Microsoft and Google spend a lot of time trying to make that very predictable and normal so they can automate it like crazy. You don't get that luxury at smaller scale. And so what we ended up doing was basically building a whole bunch of orchestration to deal with that sort of variation within the environment. And then the other pattern that we saw in this that makes it really important even at smaller scale is that it's very iterative. It's not that people set up gear and walk away from it, right? Every deployment we ever saw, you set it up, you test it, you tweak it, you reset it up, you test it, you tweak it. What we learned, and really learned the hard way, was that it was really a question of how quickly you can turn those environments, and we focused on making the turns faster, not eliminating the turns. And that was a watershed moment in design for Crowbar. Was we gave up trying to make our designs better. We just made our iterations faster. And that doesn't matter what scale you are. If you have 5 machines, if you can bring in something that lets you iterate through faster so that you deploy more consistently, that's a win.
What's involved in some of those turns, Rob? Like what are some of the things that go into it?
So what we found was, especially going into a new deployment, was we found that you definitely had RAID and BIOS configuration tweaks that you would make, and sometimes there were patches in the BIOS or changes in the BIOS, but mostly they were networking changes. That somebody would say, hey, I want you to switch and use this VLAN instead of that VLAN, or I gave you the wrong subnets, or the way you did the gateways on these systems was wrong, or now you deployed with CentOS 6.5, but 6.6 came out, and now so you're going to re-image all the systems to get the latest OS because you want to be current. Dependency graph changes were a huge piece of it. Those were big ones. When we were doing OpenStack, you would find somebody would find a bug. Once you start performance testing, somebody finds a bug, you have to propagate a patch. Sometimes that patch has implications in your network configuration or your disk configuration. If you enumerated your drives wrong on your Swift deployment, that could cause you to need to re-image or rebuild the whole system. It didn't take much, is what we learned. For somebody to say, all right, I want to tweak this and then rebuild the whole environment. And since it's not just OpenStack, but most systems are not very good about doing upgrades, especially as you're doing a deployment. If you don't have data, you just roll out, you flush and roll out the whole system again until you get it right. And we would do it 5 or 6 times. Once we had it fast, you would show up on site, you'd put down your baseline, without even worrying about what there should be, just to prove that the gear worked. And then you would start rolling through adaptations to the customer environment 5 or 6 times. So we could do it in 2 hours. And then you performance test, you benchmark, you find if there's errors. We find one machine could be misconfigured. And the faster you go through that cycle, the better. You flush out bizarre stuff. We had a case where somebody had patched the BIOS on their switches, and it caused the whole site to fail after a reboot. So it was all working great. We rebooted, and the switches went belly up because somebody had patched the BIOS.
When you say, where did they get these patches, or what were they trying to do?
The network team had gone in and wanted, before the install, they had come in and put in a new patch of the network operating system, and that patch had a bug.
It was just something that was not discovered till a reboot.
Right, and the danger that we saw, and this is interesting because it was with Crowbar, was that because we were so automated, we would expose issues within the infrastructure really fast. And there were a lot of times where the Crowbar team took the heat on an install because we exposed something quickly in automation, like BIOS issues or network switch issues or OpenStack configuration problems. And this is the danger of automation. You're very sensitive to any things that are misconfigured in the infrastructure. You have to be able to make your automation really robust.
I mean, in some sense, you're just as sensitive when you're doing things manually. You're just going much slower.
The people have a tendency either to miss it, and you're right. So you just sort of walk past it, or you go slower, and the person sort of fixes it in the background without even realizing that there was an issue, which is not really a scalable model.
Certainly not the way when we were talking about 50,000 hosts in a pod or data center or whatever. You're not going to do those all by hand.
Totally, but even if you only had, let's say we had 20. If I wanted to do an upgrade of that, and there's any snowflaking between those 20, my upgrades aren't going to be successful.
What do you mean by upgrade?
Upgrade would be going from OpenStack Havana to Juno, right? Or moving through a Cloud Foundry upgrade from one release, and I don't know your release nomenclature, but from one release to another, you need to know what those systems are so you can upgrade them. If they're slightly different, your upgrades are going to be in very weird states.
But if you're deploying something like Cloud Foundry on top of an infrastructure, whatever it happens to be, um, if there's variance, the tools Bosch is going to pick it up when you're doing the deploy, when there's a canary or something else and there's something wrong. And at the same time, I would argue there has to be a compelling reason for me to want to update, or I'm going to leave my stuff alone. In other words, I'm not just going to upgrade my infrastructure or my BIOS just for the purpose of upgrading my BIOS to the latest. There has to be something really broken for me to mess with it.
I mean, I think sometimes this kind of is reinforcing Rob's point about automation and abstraction. It's like you assume everything below whatever layer you want to build on top of is going to work, and that's not always the case. And then when it doesn't work and you've assumed it will work is when it bites you the hardest.
Totally agree, which would be every enterprise app written until maybe 5 years ago.
And every enterprise app ever, right? I mean, sort of to your point, like lots of people do that, right? They're running these old versions. In many cases, they don't even have the security patches, the stuff that you'd probably, if you were sensible and cared about things like, I don't know, people getting on your servers, then you would fix them.
That's right. I would agree.
And I think what I'm excited to see is cloud disciplines where people are much more elastic and they're much more willing to turn their environments quickly, coming down into physical.
And I think,
we're
I
trying to catalyze our physical gear.
Well, in some sense, the gaps that something like Crowbar needs to fill, those have to happen before what you're talking about is even possible for most people.
Right. No, Crowbar's an enablement for this. That's exactly how we see it. It's part of the vision is that we're trying to take what I see as operational practice, and it's not cloud or physical or anything like that. It's best operational practice that we can refine in cloud, and then we're driving it down into physical because it's best practice. It has nothing to do with whether it's virtual container or not. But we just don't have the automation frameworks to do it until now. I feel like we're close. I think we still, we keep finding some interesting nuance as we try and do things like Team's adding CoreOS right now.
Yeah.
And CoreOS is different than CentOS or Ubuntu. There's different assumptions and there's things you can't do, and we're trying to figure out how to change the orchestration to adapt to that. We had to adapt it to deal with Docker. Same thing.
So we've moved into the second hour, and as much as I'd like to stay up all night and talk about computers, we should probably look towards wrapping it up. And I think we had a great discussion. We never really got to anything with the foundation, but containers, data, and then bare metal provisioning are all interesting and relevant to at least my interests, and I'll subscribe to this newsletter. But before we finish, does anyone have any ahas or things they want to kind of throw out about anything we talked about tonight or anything kind of coming up in the immediate future? And then this is the last one before Thanksgiving, so if anyone wants to throw in anything they're kind of thankful about, then that's also welcome.
I do want to throw one thing out that Tim Crawford on Twitter mentioned. He asks the question, if hyper-standardization of hardware is a requirement, does that inherently eliminate 98% of today's enterprises?
That's a very nuanced question that I think would add another 20 minutes to this conversation.
It does, but it's a very interesting question.
I think we should start with it next Sunday.
That sounds good. I agree.
Tim,
Check out the Intel Xeon
Are you sure that, and this is extending the
It's a
invitation.
reason for me to come back in.
We'll extend the invitation for Tim to join us.
I'm sending the invite now.
He joined for about 30 seconds earlier in the hour. So for me, Andrew, since you prompted us, I'm thankful that we live in interesting times. Like we talked about earlier about how containers are being adopted more quickly than it seems like than virtualization was adopted. Like we're only about a year and a half or so since Docker was announced, and and how much it's just pervasive across now both Google and Amazon having services built on top of it. And then if you look at how much longer it took virtualization to get out, so I think it's just a lot of fun to be in this space. So that's what I'm thankful for.
What we need to hear from Caroline and Abby before we go.
You won't hear from Caroline. She just had to run out and take care of something. So
Duty calls.
yes.
I'm thankful I'm on such an awesome team. How about that?
Team Cloud Foundry. Well, unless anyone else has any thing they want to add, I think we'll call it a Sunday, and everyone have a happy Thanksgiving, and we'll see you again next week.
All right.
Rock on.
Cheers.
See you guys.
Good to see you all.
Cheers.
Bye. Thanks.